Hello everyone, I'm Cynthia. Previously, we focused on a series of discussions about the enthalpy difference laboratories engineered for vehicles. First is application of air conditioning in different vehicles, which includes automotive air conditioning, bus air conditioning, train air conditioning, and so on. This type of testing equipment is generally also an enthalpy difference laboratory, except that additional fixtures are designed to match different types of air conditioning units for installing the tested units. Moreover, for air conditioning systems like those used in buses, which are installed on the roof and require heat exchange from the top to deliver cooling to the bottom, we need to modify the conventional horizontal structure of the enthalpy difference laboratory into a vertical structure. In other words, it is a two-story design with the upper level serving as the external side and the lower level as the internal side. Extreme operating conditions and reliability testing are another major focus of automotive air conditioning testing laboratories. For example, in the high-low temperature alternating test chamber, the air conditioning system undergoes cyclic tests of high temperature exposure, low temperature freezing, simulating scenarios such as starting the air conditioning immediately after a vehicle has been exposed to intense summer heat or initiating heating after prolonged parking in extremely cold regions. These test the system's startup response speed and long-term endurance. Furthermore, the salt spray corrosion laboratory is used to evaluate the corrosion resistance of metal components such as air conditioning pipelines and heat exchangers, simulating high salt spray environments in coastal areas to ensure that parts do not develop failures like refrigerant leaks due to corrosion over long-term use. For new energy vehicle air conditioning systems, the laboratory also conducts low-voltage startup tests to verify whether the air conditioning can maintain basic operation when the battery is low on power, while balancing energy consumption and range. Now, after we have had a look at some specialized air conditioning laboratory designs, we are going to explore the Automotive Thermal Management Laboratory. The Automotive Thermal Management Laboratory involves placing the entire vehicle inside the laboratory to test energy distribution under simulated temperature, humidity, and climatic conditions. In summary, it provides a testing environment for new energy vehicles, allowing engineers to adjust the electrical energy distribution for the new energy vehicles to adapt to different operating conditions. The environmental chamber is one of the core facilities of the laboratory. This enclosed space can simulate extreme climates from severe cold to intense heat, with a temperature range covering -40 degrees to 80 degrees, while also precisely controlling parameters such as humidity and wind speed. Whether it is a cold winter snowstorms, or it's the hot summer heat wave, or even the low-pressure environments of high-altitude regions, all the climate can be accurately replicated in the environmental chamber. Engineers can place entire vehicles or core components such as engines, battery packs, and air conditioning system inside the chamber to test the response speed and regulation capability of the thermal management system under different operating conditions. For example, when testing the thermal management of new energy vehicle batteries, the environmental chamber simulates faster charging scenarios under high temperatures, monitoring the battery temperature change curve to ensure the battery remains within the optimal operating temperature range, avoiding safety hazards due to overheating or reduced range due to excessive cold. The establishment of automotive thermal management laboratories is not only related to vehicle performance and safety, but also closely connected to energy conservation and environmental protection. An efficient thermal management system can improve engine thermal efficiency by several percentage points and increase the range of new energy vehicles by tens of kilometers. As a mission of lowering carbon emission, laboratories are continuously exploring new technologies and materials, such as adopting integrated thermal management modules that combine cooling, heating, and waste heat recovery functions to reduce pipeline redundancy, and developing new insulation materials and efficiency heat exchangers to further enhance energy utilization efficiency. That's all for today. Next time, we'll look at how to test the components of air conditioning. Thanks for watching and see you next time!